When people say they want LLM experience, they usually don't mean pre-training a model from scratch. In most roles, what matters is instruction tuning, taking a capable base model and making it follow tasks, formats, and domain-specific behavior reliably. Hiring managers care about whether you can improve usefulness, safety, and evaluation in practice. So the key is showing you understand where pre-training ends and product-ready model adaptation begins. Here's the core distinction. Pre-training is the first phase. The model learns in a self-supervised way by predicting the next token across huge amounts of text, which gives it broad language ability. Instruction tuning comes next. It uses supervised examples of prompts and responses to teach the model how to follow human requests. A simple way to think about it is this. Pre-training builds the engine, and instruction tuning turns it into a car you can actually drive. This slide shows where instruction tuning fits in the overall stack. We start with pre-training on a massive unlabeled corpus, using next token prediction. Then, instruction tuning uses curated input-output examples to teach the model how to follow requests in a useful way. After that, preference optimization, including human feedback and RLHF, helps align behavior. Together, these stages enable deployed products like assistants, copilots, and autonomous agents. Here's this side-by-side difference. Pre-training teaches a model by predicting the next token across massive unlabeled text, using self-supervision and enormous compute, so it's usually done only by frontier labs. Instruction tuning is different. It trains the model to follow labeled prompts and responses. Because it uses curated or synthetic task pairs and supervised learning, it's far more accessible to startups, enterprises, and even individual teams. Here's why this matters for your job search. Most LLM roles aren't about building frontier models from scratch. They're about taking existing models and adapting them well for real use cases. That's what employers want to see, that you can run supervised fine-tuning, evaluate the results, and deliver reliable behavior. And the good news is, instruction tuning is actually reachable with open models and relatively modest compute. Here's the key data difference. During pre-training, the model learns from massive amounts of mostly unlabeled web text, billions or even trillions of tokens, with no explicit task structure. Instruction tuning is different. The data is curated or synthetically generated and organized as instruction-to-response pairs. That gives the model clearer signals for specific tasks, conversations, and structured outputs, so it learns not just language patterns, but how to follow requests. Here's the standard vocabulary you'll hear in interviews, and people often use these terms interchangeably. SFT, or supervised fine-tuning, is the operational term most companies use for instruction tuning. Instruction tuning means training on instruction and response pairs to connect next token prediction with actual user intent. Then there's RLHF, reinforcement learning from human feedback, which often comes after SFT. Preference optimization, like DPO or PPO, pushes alignment further using ranked human preferences. Here's the modern tooling stack we use for instruction tuning. Hugging Face TRL and especially SFTTrainer simplifies pre-processing and manages the training loop for instruction-style datasets. LoRA and PEFT make fine-tuning much more efficient by updating a small set of parameters instead of retraining the entire model. And with open-base models like Llama, Mistral, and Falcon, we have strong starting points that are well suited for adaptation. Here's the basic SFT workflow. We start by collecting prompt response pairs, then format them into the structure the model expects. Next, we load the base model with LoRA adapters and train it using SFTTrainer. After training, we evaluate the gap between training and validation loss. A healthy run shows only a small gap, which tells us the model is learning patterns that generalize, rather than just memorizing the training examples. When talking about evaluation, interviewers want to hear three things. First, compared to prompting alone, did the model's behavior actually improve? Second, look at train versus validation loss. A small gap suggests the model is generalizing, while a large gap usually means it's memorizing. And third, inspect failure modes directly, like excessive verbosity, hallucinations, unnecessary refusals, or outputs that break the expected schema. For Portfolio Project 1, I recommend a narrow domain supervised fine-tuning build. Start with a real business workflow. Create a small, high-quality instruction dataset and fine-tune an open model using SFT or LoRA. In your presentation, show clear before and after outputs. Explain how you curated the data. Include training and validation loss curves, and make the case for why prompting by itself wasn't enough to get reliable results. Portfolio Project number 2 focuses on structured output reliability, which is a strong signal for AI engineer roles. The idea is to fine-tune a model so it consistently produces valid JSON, policy-grounded responses, or support action schemas. This stands out because it maps directly to real production needs, tests schema compliance instead of just fluency, and shows you understand how reliable output formatting works in practice. There are really 3 questions every interviewer asks here. First, why use instruction tuning instead of just prompting? The key is reliability. Prompting alone usually can't enforce consistent format, tone, or domain-specific behavior at scale. Second, what actually changed after tuning? That's where clear before and after examples matter, ideally with measurable improvements. And third, how did you evaluate it? You want evidence like loss curves, held-out evaluations, human review, and task-specific metrics. This is where the frontier is starting to shift. Traditionally, we think of pre-training first and supervised fine-tuning after, but newer work is testing whether instruction-style learning can start earlier, even at pre-training scale. In an interview, I'd frame it carefully. The standard pipeline is still the default, but hybrid approaches are emerging, and it's worth showing awareness without overstating how settled the evidence is. Different roles care about different parts of the fine-tuning stack. An LLM engineer focuses on the SFT pipeline, tooling like TRL and LoRA, and how we evaluate results. Applied scientists care more about data quality, loss behavior, and whether the model is truly generalizing instead of memorizing. Product engineers want reliable structured outputs and format compliance, while agent or copilot developers prioritize strong instruction following, schema adherence, and the overall alignment stack. Here's the practical strategy I'd recommend. First, learn the vocabulary well. Pre-training, supervised fine-tuning, preference optimization, and evaluation. Then build one real project, ideally instruction tuning for a specific domain task using open models and Hugging Face TRL. Use efficient methods like LoRA and PEFT so you can experiment without huge compute. And finally, tell the evaluation story clearly. Data quality, loss curves, failure cases, and what actually improved. Here's the clean mental model. Pre-training is where a model acquires broad capabilities by learning from massive amounts of data in a self-supervised, compute-heavy process. That's the foundation model stage. Instruction tuning comes next. It adapts that model's behavior using supervised examples so it can follow prompts and act more usefully in products. In short, pre-training teaches a model to continue text. Instruction tuning teaches it to respond to instructions. Here's the big picture. Focus on supervised fine-tuning. Because most real-world AI jobs are about adapting existing models, not training them from scratch. Employers want to see that you can actually run an SFT pipeline end-to-end, not just explain what it is. What really stands out is strong evaluation, good data, healthy loss curves, and clear failure analysis. And the best part is, you can start now and build a solid project this month.